Evening all. Am I audible and visible?
Yeah.
Yes, yes.
Okay. Good evening, ladies and gentlemen. I warmly welcome you all to the 42nd talk of the Inter-Society weekly webinar series. Today, we're extremely delighted to have the renowned chemical scientist and former Deputy Director of VSSC, Dr. K. Nand with us. He will be giving us an insight into India's maiden Mars mission, a unique accomplishment in science and technology. On behalf of all the attendees present here, with utmost honor and privilege, I welcome you, sir, to the 42nd talk of the Inter-Society Weekly webinar series. It is also my privilege to welcome S. Radhakrishnan, sir, and Miss Akhila Gauri Shankar as well. I would also like to welcome the MC of our session, Fida Fatima, who is doing a wonderful job. Last but not the least, I would like to welcome all the attendees. Over to S. Radhakrishnan, sir, to introduce the speaker. Thank you.
Thank you, Nesma. Good evening and good morning to other certain people outside our India. Let me first thank Mr. Harinder Lal, Chairman, Inter-Society Weekly Webinar Series Committee for giving me an opportunity to introduce the speaker of this to this August audience. I'm also delighted Dr. K.N. Nainan, an outstanding scientist from BSSC and a Deputy Director from BSSC Isro, and former Emeritus Professor of Indian Institute of Space Science and Technology, popularly known as IIST Trivandrum. Born in 1946, he had his BSc degree in chemistry from Marthoma College, Tiruvalla. Subsequently, he took his MSc chemistry from Maharaj College, Ernakulam, and PhD from University of Kerala. He had 40 years of experience in different capacities in BSSC, starting from propellant engineer and superannuated as deputy director of BSSC Isro. Following are his achievements. He established the state-of-art of chemical characterization facility, made significant contribution for the development of various types of solid propellant, polymer, etc. Authored 196 publications in international journals, and to his credit, 28 national and international patents. That's a very great thing. And he has guided 28 PhD scholars. Recently, in 2020, he was ranked among the world's top 2% scientists by 2% scientists by Stanford University, USA. He was recipient of the following awards: ISRO Performance Excellence Award in 2009, received from President of India; Lifetime Achievement Award in 2013 and 2019; NUTS ITAS Award from Indian Analytical Society in 1987. He was the past president of Kerala Academy of Sciences, Society of Polymer Sciences, High Energy Materials Society. Also, he is a distinguished visiting professor of Indian National Academy of Engineering in CUSAT. Also, he is a member of International Academy of Astronautics. This is all about our speaker today. Over to Mr. Nesma. Fatima, sorry, Faida.
Thank you, Radhakrishnan sir. So we had a really good introduction of Ninan sir. We are really happy that we have you with us to speak today. And now, sir, it's over to you for your address. You can just share your screen and start presenting as well. We'll be happy to see you, to hear you.
Thank you, my old colleague and also President of our Pensioners Association, Mr. Radhakrishnan, for the nice words of introduction and also introducing me to this webinar program. I suppose I am audible to you, am I?
Yes, sir, you're audible, yeah.
Okay, good. I also thank Mr. Harinder Lal, the dynamic chairman of Inter-Society Webinar Coordination Committee, for inviting me to deliver this lecture. I'm indeed delighted to note that this is the 42nd lecture. That means you have a record of 41 webinar series. And also I am very happy to know that unless people are interested genuinely in knowing about the latest trends, it would not have sustained so long. It's a privilege for me to address this highly enlightened audience of six different professional societies who are deeply interested in various fields of science and technology. Ancient India, in fact, was in the forefront in science and technology. I'm sure you would have heard about the first surgeon or astronomer Aryabhatta, or the unknown metallurgists who have made the iron pillar in Delhi. But in the modern science, which started, I should say, with the Galilean period, at least half a dozen countries have overtaken us in the areas of science and technology. Therefore, it's extremely rare for us to hear about something that we could do initially or for the first time, which these countries couldn't do. Therefore, it's my privilege to tell you a story of an unparalleled achievement of India, which these countries, or in fact, no other country could do. So I shall start sharing my presentation. Is it visible to you? It's visible to you, I hope so.
Yes, sir.
Okay. So this is a great feat of achievement, which is achieved by ordinary scientists and engineers like you and me, who have passed out from our ordinary colleges. A feat about which every Indian can be proud of. That's what I am going to tell you today, the story of India's Mars orbital mission. I'm going to tell you a story which lasted 10 months and 21 days in about 45 minutes. And therefore, I request you to listen to me properly. At the end of the story, I'm very sure I can convince you that yes, we can. Because yes, we did. Okay. So, why an unparalleled accomplishment, you may ask? If you look at the overall success rates of Mars mission, the spacecraft going flyby or orbiting or landing with or without rover, the mission so far done, the success rate has been less than 50%. Out of the 55 mission, only 27 has been successful. But the astounding thing is seen in the next slide, where you see the history of the first attempt to Mars. You look at this, there are 6 countries have attempted, and all except India, it was a failure in the first attempt. Even a veteran like USSR succeeded only in the 10th attempt. You may say that this was because they did it long ago, but look at our neighbor who did it very recently in comparison to India. That itself was a failure. So India is the only country in the world to succeed in the very first attempt, and the only Asian country to reach a Martian orbit. I'm very certain if it was a open meeting, all of you would have clapped. You can clap at your home. I don't mind doing so. Okay. So in my lecture, I'm going to answer to you 3 questions. One is why we went to Mars, how our spacecraft Mangalyan, meaning Mars craft, Mangal for Mars and Yan for craft, how our spacecraft went to Mars, and what are the lessons we learned from the Mars orbital mission, not only the technical one, but for the general assimilation of all of us. So there was global interest in Mars from ancient times. For example, the name itself came from the Roman god, and many in India, I think even today, also afraid of Mars. There is what you call Chova Dosham and whatnot. But then a better scientific understanding of Mars came with the invention of telescopic image, with the advent of telescopic image. Looking at that, people postulated that these type of crevices are due to rivers and canals in the past. And in fact, when I was a youngster, when I was in the schools, every day there would have been a story in the newspaper about some people seeing somebody moving around on the Mars. And there are civilizations in the Mars and so on. But today we have a better understanding thanks to the space exploration from the spacecraft which should go near Mars or land in the Mars. So these are the special features. This is a picture of Mars and Earth, diameter of half of that of Earth, mass 1/10 of that of Earth, and therefore the gravity 1/3 of that of the Earth. 1 year is 687 days, and 1 day of Earth day, and our days are more or less the same, only 40 minutes difference. The average, Mars is pretty cold. The average temperature is -63. Atmospheric pressure is 0.6 atmosphere pressure compared to 1 for the land, for Earth. And we have a clear understanding of the atmospheric constitution, more or less, at least for the major constituent, 96% of it is carbon dioxide. But Mars is very dry. There is no liquid water on its surface, even though there are some postulates which say that underground there is liquid water, salty water is there. However, there is 20 million cubic kilometers of ice plus solid carbon dioxide at the polar region, what you see here as a white patch. So the hypothesis is that about 3 billion years ago, Mars had liquid water on the surface and microbial life on it. But a bit more conclusive evidence of microbial life would come from methane gas in Mars, because 90% of methane on Earth is produced by microbes. So methane can therefore indicate the presence of microbial life on Mars. In fact, some of the missions to NASA and European Space Agency have indicated the presence of parts per billion range of methane in Mars atmosphere. However, there has been no concordant results, no agreeable results among all the people concerned because of the very low percentage. So the search for methane, and through that the life in the primitive form continues so far as Mars exploration is concerned. So, however, there is a big challenge to go to Mars because of the enormous distance and the differential speed. There is about, this is the average distance of the orbit from the sun. There is about 80 million kilometers difference between, average difference between the two orbits, and the speed is also enormously different. So Mars mission is like a slingshot to a very fast moving object, which is millions of kilometers away. So the current global interest in Mars, I will reiterate, one is to confirm the presence of methane and therefore life on Mars, to establish the location, amount and nature of water on Mars, because that is needed for its settlement or going beyond Mars. Second one is exploration of rare minerals. It is projected that in 25 to 50 years, almost all the rare metals from Earth will disappear. Therefore, we have to explore, and the nearest planet is Mars. And Mars as a future habitat or intermediate station to distant planets. For example, if we find a better planet to live in a solar system away, then obviously at one stretch we can't go, so we have to have some intermediate planets. That is why people like Stephen Hawking said that human beings have to find new homes elsewhere in the universe because of global warming, nuclear war, or genetically engineered virus. Even our coronavirus is that or not, we don't know. So this is one of the great dream of human beings, is terraforming. That means convert Mars from this structure to this structure, and then, you know, make it settlement. For example, this is a visualized perception of SpaceX company of USA. After 20 years, this will be a Mars settlement with rockets ready to go up and down. And in fact, they have gone beyond just visualization. They have, in fact, built a prototype of a 100 passenger capacity spaceship here, and also a massive rocket called Super Heavy. Its combined mass is 5,400 tons and its height is 120 meters. And its maiden flight to Mars is expected now in 2024, and crewed flight will be in 2027, preceding the settlement. Compared to this, you know, many others also, just to give you an idea, many others have also came out with an idea like Mars one in Holland, who without any proper foundational planning called for volunteers to go to Mars, and our poor girl, she was selected and is disappointed because the company is wound up now. So what I want to tell you, especially the students, is that your ambition is okay, but it has to be followed up with proper planning and then proper foundations for that. So India's current mission, the objective is not that high. What we planned is to develop technologies which are required for an interplanetary mission. And after deciding to go there, why not explore Mars surface features and atmosphere using indigenous scientific instruments? We have decided that we will have only Indian-made instruments because that will give us a lesson to learn in building, you know, instruments required for future interplanetary missions. So let us see, after having decided so, let us now look at what are the elements for a Mars mission. First is you have to have a suitable launch vehicle. Then you have to design and realize this suitable launch vehicle from the available ones, because we have got launch vehicles. Then realize and design and realize the orbiter, which is new. Design a trajectory to Mars, because we have not gone there earlier. And deep space communication and navigation, which is partially new because we have gone a short distance to the moon, but compared to that, this is much more distant. So ISRO's launch vehicles, these pictures you would have seen. You see, these are two beginners in early 80s called SLV-3 and ASLV, but its payload capacity is very small in the low Earth orbit. But what we have used is the PSLV, which is an operational launch vehicle. It has a capacity of putting 1.8 tons in the sun-synchronous polar orbit, or 1.4 tons in a geostationary transfer orbit like this. From there, it is taken to the geostationary orbit 36,000 kilometers up using the spacecraft propulsion itself. It is a highly reliable and cost-effective one. However, if this was available, GSLV Mark II, people asked why not use GSLV Mark II, which was available at that time, which has got a capacity to carry 2.5 ton as against 1.4 ton to GTO. However, for such missions, we look at the most reliable ones. At that time, we had 6 flights, out of which 3 were unsuccessful, and therefore we decided to choose this. But today, if I were to make a choice, I would go in for Mark III, because it has got a payload capacity of 4 tons in the geostationary transfer orbit. Okay, so we have chosen the launch vehicle. What next? Next is design and realization of the Mars orbiter, which was done at URO Space Center in Bangalore. But the spacecraft, unlike the other spacecraft what we have made so far, it has to have totally autonomous features, because the two-way communication takes 24 minutes. So if something happens in the spacecraft, we cannot wait for that much time to do. So this is the spacecraft Mangalyaan, having a mass of 1.34 tons with 850 tons of liquid propellant stored. Why this liquid propellant for? Because it is needed to fire 2 liquid engines in the Mangalyaan, which was made by the Liquid Propulsion System Center. That is for orbit racing, attitude control, and other maneuvering. So there is a main engine, this long, flame is from the main engine, which is a 440 Newton liquid apogee motor, and 8 small thrusters which are for steering the spacecraft. They are 22 Newton thrusters. The propellant used in Mangalyaan was developed in my group, and it has oxidizer is mixed oxide of nitrogen, 3% nitrogen oxide and 93% N2O4, and fuel is monomethyl hydrazine. Well, this was developed under the dynamic able leadership of late Mr. Mark Group. Handing over to Professor U.R. Rao, who was the satellite project director at that time, later became chairman Isro. Behind him is Dr. Muthayam, who was the director of this center. At that time, we were handing over the propellant in a Manana Pata like thing. This was a carbo in which we were handing over. But today, we are handing over in this type of huge vessels, in this type of trucks. We have established our own plant in Mahendragiri and operated by our own people. And we have established a plant outside. In fact, that is one of ISRO's philosophy. If somebody outside can do to our quality requirement, we get it done outside under a secrecy agreement. This is done at Andhra Sugars Private Limited in Tanuku, Hyderabad. Tanuku in Andhra Pradesh. There are 5 measuring instruments on board of Mangalyaan. All of them were indigenously developed and made. And the total mass of the 5 equipment is only 14 kilograms. A terrestrial type of those 5 instruments together would weigh something like 1.5 to 2 tons, almost 1,000 times this weight. So one is a methane sensor for measuring, which is an infrared radiometer. Then Lyman alpha photometer H2D2 ratio, and then a quadrupole mass spectrometer for measuring the constituents in the upper atmosphere, and an infrared imaging spectrometer for surface combustion analysis, and of course, an inevitable part of a camera, some made in Ahmedabad, some in Trivandrum, some in Bangalore, and so on. Okay, so we have the launch vehicle, we have the instrument, we have the spacecraft ready. Now we have to go to Mars. This is done in 3 steps. One is you have to leave the sphere of influence of the Earth, then cruise to Mars, and then enter to the Mars atmosphere. First, we will see leaving the sphere of influence of Earth and getting injected towards Mars. This was done on November 5, 2013, launched by PSLV into 250 by this 23,000 kilometers elliptical orbit. I have indicated how much propellant was used for this initial step because that is overcoming the gravity of the Earth, whereas all subsequent things have used less than 500 kilograms of the propellant. See, for example, this was the original thing done by the PSLV. The remaining 6 orbit racing maneuvers, including final injection towards Mars, was done by the spacecraft propulsion, which used only 447 kilograms of the spacecraft propellant. Then, next is to cruise to Mars with minimum energy propellant utilization. Because this is a pictorial representation of Sun, Earth, and Mars. In this configuration, the distance is minimum. However, enormous amount of energy or propellant is needed to travel this short distance against gravity. Whereas, if you go from Earth to Mars around the Sun, which will obviously be a much longer route. In fact, once you are in the Sun's orbit, no fuel is thereafter needed, provided you are in a stable orbit. Provided after you leave, you will meet Mars at the correct point, at the correct location. So the spacecraft was placed in an orbit, which is called a modified Hoffman transfer orbit. Because you are engineers, I thought I will spend a minute on what is Hoffman transfer orbit. Hoffman transfer orbit, which was predicted by the brilliant German engineer, scientist about 1925, much before raising or having a stable orbit around the Earth, is an elliptical transfer orbit around the Earth. So, in that, if you increase the velocity tangentially, then the spacecraft will enter into this elliptical transfer orbit. And when it reach at this point, there is an apogee burn again, increase the velocity tangentially, it will change over to the circular orbit. This is the mechanism of raising the orbit of an artificial satellite. Now let us see how to go, but then only one condition is that the orbit as well as the central bodies are to be in the same plane. Now, to reach Mars, we should have Earth at our leaving position, and we should have Mars at the arrival position. At the end of this transfer elliptical orbit around the Sun, all should be at the same plane. But this required alignment happens only once in 26 months. That is why the criticality of launch window. If you had missed that launch window in 2013, then we could have had to wait for another 2 years. That is why you would have seen that just prior launch of the Chinese were 2 years earlier than ours. Then we have to optimize the trajectory. No experiment is possible. So we have to do thousands of simulations on Earth to arrive at the optimized trajectory. I request your close attention to this because this tells us about the whole mission to Mars. So this is a situation PSLV has left it here, and this was the 6 orbit raising maneuvers. At point number 1 on November 30, the velocity of the spacecraft was increased tangentially to take it into an elliptical orbit around the Sun from point number 2, like this. Then the trajectory has to be so precise. At the time of leaving here, Mars is here. And then the calculation has to be so precise that by the time Mars come here, our friend also has to exactly reach there. Then only rendezvous is possible. So in fact, our calculation and the performance of our propulsion systems were so precise that only 2 minor orbit corrections using only 0.48 kg of propellant utilization were required this entire travel. And the Mars also arrived at the same time at the same point. And the travel from 2 to 3 was 667 million kilometers, which has happened in 293 days. So at this point, we have to slow down our spacecraft, otherwise it will continue again to go around the moon, around the Sun. So what entry to Mars? That is the last phase. On reaching the sphere of influence of Mars, the velocity of Magellan has to be very precisely, again I repeat, very precisely reduced from the then velocity of 22.1 kilometer per second to exactly 1.1000 kilometers per second to be captured by a predetermined Martian orbit. So the important question is, will the engine, which was on hibernation, virtually sleeping for 293 days in deep space environment, will it work? Because it's such a complex engine, even our motorbike. Nowadays, many of you don't have a motorbike, at least a motor car. If you live in your shed for a year and come back and try to start, it will not work. You have to take it to a workshop to make it start. So what about this engine? Will it work? So that was our main worry. So what we did was 2 things. One is that we did a lot of compatibility studies on ground, which shows that it is compatible. We have designed it such a way that it is compatible. But the proof of the pudding was in eating, and therefore on T-2 days, we had a 4 seconds firing of the engine, and it gave exactly the expected results, and therefore there was great confidence in the mission. So the major event on September 24th, exactly at this time, how to reduce the velocity of the spacecraft? There is no braking is visible. So what we do is we turn it 180 degrees and then again fire the engine. So it will be what is called a reverse firing, and therefore the engine velocity will reduce. Okay, at this time, the engine was fired for predetermined time of 24 minutes and 14 seconds using about 248 kilogram of propellant. The velocity was reduced. See, look at this figure, 1.099 kilometer per second, which was within 0.1% of the target. So this was a near perfect performance of our propulsion system. So the spacecraft was then turned back to the normal position, and exactly at 8:00, we had the confirmation of Mars orbit from Canberra. Okay, so see, look at this. This shows a near perfect. If it was possible for a scientist to call a perfect mission, I would have called it a perfect mission. But as you know, there is nothing perfect on possible in any experiment. That is why I call it as a near perfect mission. This was our prediction. As against this is what we got, and we had sufficient propellant quantity for more than 1 year of life. So this is the first color picture obtained from Mars, presented to our Prime Minister. And so India is now the first country in the world to reach the orbit in the very first attempt. Not only that, we have joined the elite group of 3 spacefaring nations, who are the only other 3 countries, USA, Russia, and Europe, who have reached Mars. Not only that, compared to them, this is the most cost-effective Mars mission to date. This is our cost, but compared to that, this is our cost. Compared to this, look at the other cost of other countries, Japan, Russia, China together, NASA, and European Agency. Not only, we realized it in a record time of 15 months. All others, it was 2.5 years to 3 years, but there was no secret. I will share the secret with you. There was no mantra behind this. It was because we had a PSLV vehicle ready for it. Had we had to have a vehicle prepared for this purpose, we would have also taken 2.5, 3 years of time. So it was performed beyond the mission objective. Original mission objective was only 6 months in orbit, but today, not today, way back in September last year, it has already completed 6 years in orbit. And this was a picture taken of the Mars moon on July 2020, showing that the instruments are intact. So, my dear friends, this is a glorious example of the quick and innovative and low-cost way of doing Mars, a major task by India. But then look at this cartoon which came in New York Times, a space club and Indian with a cow knocking at the door. There was a lot of fury all over India, but in my mind, there was no fury. In fact, according to me, this is a compliment. Why I say this is a compliment? Because this shows that in spite of being backward, we have achieved it. So you don't have to be an elite by caste, creed, or color to do great things. You don't have to be a MITian. You don't have to be a Harvardian to do great things. That is what we have shown. In fact, Isro itself is a typical example. We had a very humble beginning, starting from a church building, which was our first laboratory, and a parsonage here, which was the place where a rocket were assembled. We were the last to enter the space arena compared to other spacefaring nations, and ours was purely a civilian program, whereas all others had military support for the program. In spite of that, we are top in utilizing space technology for societal application. This is because of the vision of a great visionary, Vikram Sarabhai, the founder father of India's space program. Looking at these tiny rockets rising from Tumba, he had a vision going beyond indigenous sounding rockets to use space technology for the benefit of the common man, which was reflected in his UN speech at Geneva in 1969, where we said, we must be second to none in application of advanced technologies like space technology to the real problems of man and society. This picture was incidentally one of my prized possessions, which was taken when Dr. Sarabhai inaugurated my laboratory in 1971. So I was a 23-year-old man. I had a lot of hair, and I should say that I was handsome also. I suppose this is Dr. Sarabhai, who was very handsome and magnetic personality at that time. You know, this our research and development activity on rocket propellants and chemical. Suppose we had a physical class, I suppose all of you would have enjoyed this joke, no? Okay, about my handsomeness. That's what I want to tell you. So the R&D on rocket propellants and chemical systems in Isro commenced in a small asbestos building, which we have preserved even now. From here only all the propellants, all the chemicals, all the material systems were developed and evolved. So from this humble beginning, in today we have a very mature Indian national space system of our own satellite launch vehicles, launch and tracking facilities, and we are one among the 5 nations in the world having these capacities, providing nationwide service in communication, weather monitoring, disaster management, education, health, management of natural resources, etc. I don't have time, neither the scope of the lecture is to give the detail, but just to give an example, telemedicine from AIMS in Kochi, 22 similar ones are there. We can, the doctors can see patients in Assam or in Car Nicobar Islands or in Jammu and where not. And fishing zone, you know, additional catch to our fishermen is worth 50,000 crore worth of additional catch since we started the program of forecasting the potential fishing zone. And then a value of life which cannot be weighed against any money. 5 lakh people died in November 12, 1970, when the Ebola cyclone was there. A cyclone of similar intensity last year before last, death toll was only 68 due to the timely warning. So Dr. Sarabhai vision became a reality through the vitality, that's hard work with passion and perseverance of those who follow, and the value of Isro, that is working together to realize a common national goal and not working for the personal glory. So Professor Dhawan was a typical example. He followed him, he materialized Sarabhai's dream to build Isro into a world-class organization. But despite our best efforts, we had failures. The maiden SLV-3 flight, for which Dr. APJ Abdul Kalam was the project director, has a failure, which was, according to me, it was the most disappointing failure of the science and technology history of India, where every Indian was expecting it to be a success. But Professor Dhawan showed us how to face the failure. He shouldered the responsibility of failure to the newspaper and media, and he instituted the mechanism of finding out solution to the problem. Today, Isro, any problem, the entire community owns the problem and find a solution to the problem. I myself was chairman of failure analysis committee in chemical area for close to 10 years, where we found the solution to chemical problem which has arisen anywhere in Isro. So it is not their job, the fellow's job to find the solution, but the whole solution. Whereas when it came to the success, the credit is shared with the people. This is Dr. Kalam sharing the results with Indira Gandhi, the Prime Minister at that time. Okay, so this is his famous quotation. Due to paucity of time, I don't read. You can read yourself. Okay. So this such a confidence only has arisen this gentleman who would otherwise gone to the deep disappointment of the failure to the first citizen of the country. So he has vouched himself by saying a confidence and hard work is the best medicine to kill disease called failure. It will make you a successful person. So this also gives us courage to explore the unknown. I mean, just I wanted to share one of my own examples. The SLV-3, you know, that what we have seen the earlier vehicle. In 1976, there was a static test where the first stage nozzle failed. There was a big discussion in ISRO. We discussed whole things. There was a big discussion because there was no facility available in the country to do a mapping of the thermophysical property of the nozzle material. There was a big discussion. Nothing is available in the country. Shall we send it to France or send it to USA? Who will do it? Then I was a young boy at the time sitting at one corner. I raised my hand and I said, then Professor Dhawan said, yes, I find a young fellow sitting there. What do you want? I said, sir, there is no need of sending it anywhere. I will do myself. Then he consulted. Of course, he wanted to confirm that it's not a mere heroism. He consulted my boss as well as Dr. Kalam, and he said, do it. So we have done, I am happy to say that we were given 30 days and we did it in 28 days, 4 weeks, and we are showing this result to Professor Dhawan. Okay, my dear friends, that confidence and hard work enable us to overcome big setbacks also. For example, you know, in 1993, there was a cryogenic technology denial to Isro. So we developed an indigenous cryogenic upper stage for which 40 specialty chemicals were developed in my group. And this is Dr. Kalam, we were explaining to him. And these are the small, it is not only a small chemical, but a 4-meter diameter, you know, a neoprene shield for the cryo tank and a special, you know, polypyromiltamide based pipe, which is the only pipe on earth which can, without getting brittle, pump a liquid at 20 Kelvin. Okay, my dear friends, the vision, vitality, and values of ISRO became hallmark of ISRO in all areas of work. For example, this is Dr. Vasant Govarikar presenting a proposal to set up a huge solid propellant plant, which has later come up with Sririkota, while we were struggling to make even a small 50-millimeter diameter motor that will work to our Prime Minister. Look at his confidence and his vision. So such confidence and vision only has resulted in us making the third largest solid booster in the world. This was our size of our boosters at that time. This is a lab technician pouring the inhibition at one end of the booster in 1969. But today, the same operation is done at Sririkota, and this is the third largest solid booster in the world. Not only that, it is the third largest booster. It develops a thrust which is equivalent to 13 numbers of the most powerful commercial aircraft engine fitted onto the jumbo jet, firing together when it fires. So, my dear, especially the student community, the lesson what we have learned from ISRO's successful Mars orbital mission is that yes, we can. You will succeed in your endeavor, whatever you have, if you have the following quality. One is have a dream and vision, have a proper plans and also confidence to achieve it, have passion and perseverance to realize it with hard work, not defeated by setbacks, but learn from failures and improve upon, and uphold values in life. Success without value is valueless. So you should have value in life. You may think that some shortcut I will succeed. No. For sustained life, you should have values in life. So vision, value, and vitality ensure victory to you. Why I am saying with confidence is because yes, we did it. Yes, we did it. This was our status when we started. Dr. Abdul Kalam assembling along with his colleague, Mr. Aruvamudan, a payload. No laboratory table available, no lab desk available, squatting on the ground. Payload being carried on a bicycle. Our laboratory in a corridor in between two rooms. This is a chemical laboratory at that time. This was the first indigenously developed solid propelled rocket being flown, 5 kilogram weighing. But today, when we launched our Mangalyaan, we had this prestigious rocket which has 51 consecutive successes in which we have flown 328 foreign satellites. Look at this data, out of which 206 are American satellites. And on November 15, we launched it. I wanted to show you if things come all right, the launch also. I hope it will come. Yeah, it's coming. Good. That is the countdown, and this is the PSLV on the flight path. It is actually a GSLV on the flight path, which is going up, roaring up to the skies. So there will be always a clap in the okay. I suppose you have also clapped. Okay, so that's all. Thank you very much for your patience listening. I am through, so I will stop sharing and I am open for your question and answer session. And also you can give about the lecture, ideas about the lecture also. Okay, thank you very much once again. So over to you, Fida, Fatima, and Radhakrishnan.
Thank you, sir. That was indeed really nice. And the presentation was also really nice, as it was very interesting, sir. Thank you so much. So we'll just move on to our question answer session now. Yes, sir?
I am ready. I am ready.
Yeah, okay. Let me just go through the questions. So there are comments on how inspiring the talk is. So that's really nice. So at present, there are there are no much questions in the chat box. So I request everyone, if you have any questions, please do post, because it's really a pleasure to have Ninansa with us. So it'll be really nice if you can post your questions. So we have comments on how inspiring, as I said, how inspiring the talk is. Even though you've mentioned, you have mentioned the failures that that was there throughout the mission. You mentioned the ups and downs. You mentioned everything. That was really nice. That gives us a sense of determination and passion to work to what we like. So that is really nice. Thank you so much. So
if you don't have any question.
Yes, sir. We have questions.
I find one question.
From Praveen Jayaman. Do we have a plan to? Yes, sir. So we have a question. Hello, sir. Can you hear me?
Yeah, I can hear you.
Okay, we have questions. I was just waiting for the questions to come. So, do we have a plan to explore materials from Moon or Mars? So that's one question we have.
Yeah, of course. Not only we, the whole world has a plan. As I told you earlier, those who are studying mechanical engineering and metallurgy, you know that the rare minerals, including even cobalt, nickel, all those things at the present rate of consumption will disappear from Earth after about 25 to 50 years of time. Not only that, there are rare minerals. Just as when you go to some town, you go to Bima Jewelry to see whether there is any worthwhile buying gold is there. So people will definitely explore if there are costly metals are there, minerals are there. So there are two purposes. One is mineral exploration. And in the case of Moon, there is a very rare thing which is maybe explored later on, what is called helium-3, which is there in abundance on the Moon. So these are the type of minerals are there. Okay, I suppose the answer is clear to you. There are plans, in other words, not only for India, but all the spacefaring nation. But the limitation now is the enormous cost. Because to bring a kilogram of gold from, say, Moon to Earth, it at the present way of going to Moon and Earth for exclusively for this purpose will cost something like 1,000 crores. Okay, I mean 500 crores at least. So when it becomes, so the effort is going on everywhere in the world to make more affordable launch vehicles, where you can have multiple missions in the same vehicle. See, we can go to Mars, make a settlement there, and then bring back some mineral. So that is why I expect that this become a commercial venture only after about 25 years, when I will not be there on Earth, but some of you guys, like Fatima, maybe one of the in that project, no, where you go to the Mars and bring some minerals. Okay, what is the next question?
Yes, another question that we have is when the Mars will be available for tourism.
Oh, sorry, I didn't hear you.
When Mars will be available for tourism? That is another question.
Mars tours. Right now, you see, poor girl like you, what was her name? I showed her name, you know.
Yes, yes. Yeah.
Sorry, at my age, I forget. What was the name? You know, one girl who was in
Yeah, we saw.
her picture, a lovely
Yeah.
girl, no? She
Yeah.
was from Coimbatore Amritananda Institute. She competed with 28,000 people in the world online, and she was shortlisted one among 100. So that was like a tourism. So to go to Mars and come back free of cost. But poor poor girl, she was ditched. Aane koduthalum aasha kodukkarunnu, there is a saying, you know. So like that. However, the SpaceX mission is a reality. It is a real stuff. So 2030 onward, 27 onwards, there will be some short tour initially on a low Earth orbit, but probably for people like you, you can have honeymoon on the moon. Okay, so there may be a reality. Moon may be a difficult proposition because there is no atmosphere there, and gravity is also a little. Maybe Mars may be a little better than Moon. So it is to it is not only that. Okay, there is another question. I saw some guy has asked. I have seen that question asked about training the people. Very good question, because we can't go to Mars without getting properly trained, because there, you know, the gravity, as I have shown earlier, is only 1/3 that of the Earth on the Mars. So you have to train yourself to live in that gravity condition. Gravity we cannot change, whereas atmosphere we can create artificial. You know, I thought some nice guy will ask me a question as what is that SpaceX plan of how to make it what is called habitable Mars Earth. Nobody has asked, so I will ask myself and give you that. Okay, that is what is called terraforming. I have shown you half the Mars gray color and half the Mars like Earth. So what the Elon Musk is a really fantastic man with great vision, like our Sharabai is. What he is planning, I will tell you. He will have a nuclear blast on top of the polar region of the Mars. Okay, so what will happen? I have told you there is a 21 million cubic kilometers of water and ice on that polar region, that white patch you have seen, no? So that will vaporize. Whole thing will vaporize because of a couple of blasts, and it will cover the entire Martian atmosphere. So what happens is Martian temperature will go up because carbon dioxide and water both are fantastic greenhouse gases. Temperature will go up, and then that water will condense and you will get liquid water. So these are the type of plan. I think fellows like you should plan for this. You should think something extraordinary. If you think ordinary, nothing will come through. At our young age, we used to do that. You know, as you know, from Maharaja's college when I came, I have not seen anything other than a bureau. But then we thought about, along with great people like Dr. Govarikar, Dr. Sharabai, Dr. Muthumayam, all those people, we also started imagining great things. Okay. Okay, next question. I even
Yes,
just
sir. Yes, sir. But it's nice hearing to you talk like this. So it's like a motivation for us, sir. Yeah. So another question: when India is planning the next Mars mission?
answer is I don't know. Maybe in another, next priority is next Chandrayaan mission.
Okay.
And then we have a Gaganyaan mission. So in between, definitely in between that, there will be a Mars mission. But the date and day, I don't know.
Yes, sir. Another question: why the rocket rolls after the launch?
Not all the rockets launch, only small rockets launch. That is, spinning the rocket gives it stability. As you know, if there is any non-uniformity in the CG is there, that will get offset. But the rocket is intentionally rolled using some thrusters to make it stable. Otherwise, it doesn't roll by itself. Only the small ones, sounding rockets, have a roll. Okay.
So we have another question from Dr. N.N. Panikkar. Any of your patents came to be used in the Mars mission?
Oh, that's a very good question. Mr. Panikkar, I can see him also. See, normally a patenting is supposed to be for gaining the money out of that, commercial level. But in ISRO, 90% of our patenting is what is called defensive patenting. Let me explain to that. Today, when we started doing it is that we found that in the late 80s, we saw a couple of US patent in India for some of the rocket parts. Their intention was once they file an Indian patent, then they can say, you can't do it, you are infringing our patent if you don't follow any such thing. So we started patenting many of our things, which are as defensive patent. Whereas there are two products for which I have filed a US patent as well as a American patent, that is advanced oxidizer called ammonium dinitramide for solid propellant and the advanced binder called glyceride polymer, because we expect that that will be the propellant system after 20 years. So at that time, there will be a demand from globally. So somebody should not flee us. That is why we have it. See, this answering Mr. Panikkar's question, see the propellant system, liquid propellant system, one of the chemical has been patented by us. Its process. Okay. What is the next question?
Yes, sir. Next question. Are we innovating on spacesuits to simplify?
Sorry, I didn't get that.
Are we innovating on spacesuits to simplify?
Space?
Space.
Space suits. Okay. Space suits. We are making space suits. That program has already started. That was again in our chemical group only. It's a 7-layer suit on which there will be, you have to have your sweat absorbed. At the same time, it should have radiation resistance, including particulate neutron radiation resistance and so on. It is under development at ISRO.
Yes, sir. Another question from Venkateshan Narayanan. Recently, we read about a rocket launched from Boeing 747. Can you place it in perspective in the race for space exploration?
Yeah, that is what is called aircraft to assist the launch. You would have seen earlier my own example of going to Mars. 95% or even 99% of the fuel within inverted comma, actually it's not fuel, it's the propellant, is to overcome the Earth's gravity by the launch vehicle. So an aid to that, to give the initial impulse from a spacecraft, keep it on a spacecraft, aircraft, what I meant to keep it on an aircraft launch, and then take it to use that as a, to carry the rocket, get it at least 1 or 0.7, 0.8 or 1 or 1.5 Mach number of that particular a particular Boeing, and then from there leave it to the rocket. So it's a delta V equation, you know. So the initial delta V from 0, you get the velocity of the aircraft. So that is an idea, but only problem is that can be used only for a small rocket. For example, look at our GSLV Mark III. Its present mass is 640 tons. With that weight, or 2000 ton is one space shuttle. Or look at our front SpaceX launch, it is 5,400 tons. No aircraft will rise up from the earth with that weight, no. So only small rockets can be. But if you have a huge one great advantage, that's a very intelligent question. One great advantage of such a system is that we can reuse that. We can reuse that aircraft after leaving it. It can come back and then reuse that. Okay, a good idea. I think guy who was asked me that question.
That was a question from Venkatesh Narayanan.
Venkatesh Narayan, I think you work on it on a theoretical paper. Give it to Isro. I mean, this idea was in air even when I joined Isro. That was in 1968. But then it has to be made viable for doing. Okay, next question.
Thank you, sir. Another question is from Zahir Bashir. So he has congratulated you on your personal achievements and contributions to and ISRO's attainments as well. And his question is, what is the secret of ISRO's success that can be transferred to other institutions in India which are not so successful? Is it the strict meritocracy?
So I think my last but one slide, I don't have time to show you that. You remember that slide, secret of ISRO's success. Have a vision, have a vitality, work for that. Not deterred by failures. Learn from your failures. Don't give up. And most importantly, in an organization, work for a cause. Not work for you. Incidentally, I want to tell you that all my publications, I have never worked for those publications. It was incidental. It was done for the students. So work for a cause, work for in a place, if 100 fellows are there, they work for 150 objectives, nothing will come through. We have yet another reason of our success is we have what you call a transparent system. Suppose Radhakrishnan comes up with a design of a liquid engine. He cannot say, I have done a fantastic thing, it will work, I am from MIT, I am from Caltech, or I am from Chandran, or whatever is there. Nothing will work in ISRO. It has to undergo a review of all. Everybody's wisdom will go. Similarly, as I told you about a failure, I was the chairman of the design review team for 10 years for solid propulsion area. Similarly, I was chairman of the failure analysis committee for 10 years. Suppose, Fatima, you make a mistake. It is not your responsibility to find a solution for the mistake. So the community joins together in finding a solution. So the community does the design review. The community does the failure analysis. The community is behind you, and the entire community works for a goal. So anywhere in the world, if anybody can work like this, there cannot be any failure. So this is the great thing which was evolved by great people like Dr. Sarabhai, followed by Dr. Professor Thaman. They have set the ball rolling, and now things will go, unless some guys will come try to spoil the whole thing. Okay.
Yes, sir. Thank you, sir. Another question from Zahir Bashir. To go to Mars or Moon, etc., it is not only the energy bar. People have to be trained to experience gravity changes, etc. So is this not going to be a bar? It is never going to be like traveling by plane, right? So, yeah.
Yeah, I think partly I have seen his question earlier and I have answered it partly. So we are setting up what is called the microgravity facilities in the country to train our Gagosian travelers. So the easiest, a short duration microgravity, if you have a parabolic flight, when the flight comes down, you get a, but that type of situations are simulated for long. So there is what is called, see, our Gagosian means India's, I suppose India's manned mission. 3 crew have been selected and they have been trained for 1 year at Soviet Union Space Station Agency for facing the microgravity conditions. So one of our friends, another Radhakrishnan, what was his initial? K.
Radhakrishnan.
We used to call him as Tadira. No, he was trained in, I think he was to go in one of the space shuttles, but in between some tragedy happened. Yes, indeed, it needs training, not only to go to the in the spaceship, but even to settle down on conditions other than that of the Earth. The biggest training is needed in terms of the gravity difference conditions. Okay, but one good thing is, you see, I can compete with Fatima and win in high jump if I go there. No? Do you agree or not?
Yes, sir. And so we'll just move.
I will compare your jump on the Earth to my jump on the moon.
Yes. So actually, even though in the beginning we had a slight delay of questions, now we have a lot of questions to answer. So
I think I am okay, but then it is getting late. I think I leave it to you.
Yeah, we'll just go on with a few more questions because the questions are also really interesting. So if you're fine, we'll just move on with some more questions.
Yeah, I am okay. I am a 75-year-old man, but I don't mind being on the floor with guys like you. It's always I feel young. Okay, tell me.
Yes, sir. Another question from Hariha. Under RS 2000 obstruction sensing warning and avoidance system for use in vehicles on high-speed highways and reduce accidents considerably.
It was a long, complicated question. I didn't get you.
Yes, I'll just repeat it once more. Can we develop an under RS 2000 obstruction sensing warning and avoidance system for use in vehicles on high-speed highways and
yeah, I got it. Yeah. That is the ultimate aim. Your driverless car, all those things go by that. And we should have a control. That is by an automated system from within. But then we should have a control from some police station or somewhere where we can intervene also. That will be a good thing. So for all these things, the prime requirement is to have low-cost access to space. Right now, it's almost 2,500 rupees a kilogram of the satellite weight to reach. If you can bring down to 2,000 US dollar, because the fun is always to say in US dollar, no? So if we can have something like 100,000 rupees, I mean, not 1,000, 10,000 rupees or so, then many other things. Already we have done space medicine. Sitting at Amrita Institute in Kochi, a doctor can see a patient in Assam. So like that, all vehicles, all those things can be ultimately, that should be our ultimate aim. Okay.
Yes, another question from Lakshmi. Is ISRO planning for a reusable rocket like Falcon 9?
Yeah. In fact, RLV technology demonstrator, that means, before going into the actual stuff, we do what is called a technology demonstrator. early technology demonstrated was, let me put it, about 10 years ago, 10 or 12 years ago, it was flown also. See, there are two types of reusable launch vehicle. It was a good question, so I'll take a couple of minutes to answer that. One is called two-stage to orbit. That means the first stage or a part of the stage is expended and a part will come back like your space shuttle. But to have a fully reusable launch vehicle, it's an ideal thing, but we should have some fantastic materials which are lightweight, which understand the re-entry temperature conditions. So and we should have some propulsion system which are till now not thought of. So the fully reusable launch vehicle is the ultimate dream of all spacefaring nations. And I hope that some of the young engineers who are sitting here, students who are sitting here, will be a party to that. But two-stage to orbit is already Isro is planning for that. The full stage, like an aircraft to fly, go up and then come down, is something which would have been the most ideal. Something which is very close to that is the one which is planned by the SpaceX, Elon Musk. Okay.
Yes, sir. Another question. In your lecture, you mentioned that reaching the orbit was confirmed by Canberra. What is the meaning? Yeah.
Canberra means it is a place in Australia.
Yeah.
So when it came, I suppose you can see my hand. When it came up, first vision was from Australia. That's all. It has to come in your radar, no? So it came first at the site in Canberra. Within a couple of minutes, it was available in India also. That's all what it meant. And it also gave us another, on a later way, it gave us another credibility. Because we said that our Bangalore has found it out, 50% of the fellows would have written next day, oh, it was all faked up. No, that was, it has come in Canberra's camera, everybody.
Yes, so another question, we'll just move on fast because time is also going. So last question, sir. What was your most memorable or exciting moment in space exploration?
That is the most difficult question to answer because for the 40 days I have spent, 40 years I have spent in Isro. Every day was exciting. Truly. Except a few days where I was very much down, where we failed in our missions, in our objective. Whatever is the result we got. For example, a couple of things I will tell you. When the first tiny rocket weighing 7 kilograms flew up just 5 months after I joined ISRO. That was in 1968. Not 5 months, 1 year, 2 months after I joined ISRO. That was a very memorable. But personally, the most memorable event for me was I was given a task as a young boy. I was just 22-years old at that time to set up a laboratory, a small lab. But I took it as a great challenge and I set up one of the best laboratory in the whole continent in the laboratory. So when in our beginning stage, Dr. Sharabai came personally. That picture you have seen, no? Do you agree that I was a smart guy at that time? You see, So that's a lot of hair. That is what I meant. You have seen that picture, no? So when Sharabai came there, that was a memorable occasion. So when our first, you see, there are like that, there are hundreds of things I can tell you. For example, in the liquid engine where our Radhakrishnan is working, there was a failure. I was put as the failure analysis committee chairman to do that. Each test could have cost some 5 crores. our committee found a solution, and when it was tested again, when it was a successful test, it was a great excitement for me. So like that, I was not telling in a later vein, but it was true that about, I should say that at least 1/3 of my life in Isro, every day was exciting, thrilling.
Yes. Yes, sir. So that's with the question, sir. And from the way you speak, we can understand how excited you was and how happy you are with your profession and about what you do. You're really happy with it, and it really reflects to our side also, sir. Even though it is an online platform, so it would be really nice to meet you in person as well. It's going to be really nice, sir. And so that's with the question answer session that we had. So now, as we come to an end of our event, I would like to request Akhila Gauri Shankar of Project Management Institute to give the word of thanks. Can we have you, ma'am?
Yes, dear. Thank you so much. Well, all will agree that it was a wonderful experience. Actually, he took us along with him. And I think he was reliving with us also, taking us through the Mars missions and all that. I'm sure everyone will agree with me on that. So that was a great program, the 42nd one from our Weekly Society series, the India's maiden Mars orbiter mission. Yes, it is a unique accomplishment and a proud moment for all of us. Thank you, Professor Nayanan, sir, for your time and the visionaries that has worked in and brought us laurels. Thank you so much, sir, for taking us through all those great moments. The way you are answering the questions, so there also you are actually getting us into all those super moments. Thank you so much, sir. And yes, thank you so much, Fida, for the great MC for the session, for today's session, and Ms. Nesma for the welcome session, and as Radhakrishnan sir for the introduction of the speaker. I am really privileged and honored to give this vote of thanks on behalf of all the 7 societies that comprise this weekly webinar series, that put up this weekly webinar series for all. So thank you everyone from the organizers of IEEE Kerala Section, the Institute of Engineers India Kerala State Center IEI, Computer Society of India Trivandrum Chapter CSI, the Project Management Institute Kerala Chapter PMI, Inter-Society Trivandrum Chapter ISOC, the Vaikam Maulavi Foundation Trust Trivandrum, and the IEEE Engineering Medicine Biology Kerala Center EMBS. And yes, my vote of thanks won't be complete if I don't acknowledge the great participants who very actively participated in this session. Thank you all participants, and we look forward to you all joining next week and the details which will be said by Fida shortly. Thank you.
Yes. Thank you, Akhila ma'am. And Ninan sir, thank you so much for coming. I'm really happy to meet you. So obviously the others will also be happy to meet you as well. And we had a huge number of questions. As I said, even though we had a slight delay in the first, the questions started coming like anything. And people also get really interested in it. Your excitement is so infectious to us also. It gives kind of a spirit to work further on anything that we are interested in, sir. Thank you so much, sir. And so now we have come to end.
For me, 1 minute. As
Yes.
for me, I thoroughly enjoyed, even though it was interesting for me to speak continuously for almost 1 hour 15 minutes. It was a little tough, but then I thoroughly enjoyed. Once you enjoy a thing, tiredness will come can wait. Okay. Incidentally, if any of you see, like later on, if things are okay, suppose your college or somebody would like to hear this lecture, I can always do that.
Yes, sir, of course. Yes, sir. we would connect to you, sir. In such cases, we will be happy to connect to you, sir. Thank you so much, sir.
Okay.
Yes, sir. Thank you, sir. So now, as we've come to an end of our event, I would like to announce our next session as well. So can we have the presentation of our next session? So I will just mention it. So the presentation is not yet up, so I'll just mention it. So as we have come, this is our 40th session and for 42nd session. And we have come to an end of our 42nd session, which is organized by IEEE Kerala Section, the Institution of Engineers Kerala State Center, Computer Society of India Trivandrum Chapter, Project Management Institute Kerala Chapter, Internet Society Trivandrum Chapter, Welcome Ali Foundation Trust Trivandrum, and IEEE Engineering in Medicine and Biology Kerala Chapter. So this next session that we have is our 43rd session. And our 43rd session will be on Green Energy Initiative of CIAL, CL, and it is by A. Chandrakumar, Director, Cochin International Airport Limited. It is on the 3rd February 2021 from 6 p.m. to 7 p.m. Wednesday. And hopefully we would like to meet all of you again on our 43rd session as well. So Nilan, so once again, thank you so much. We would like to connect with you. So probably through Harindalal sir, we'll connect with you, sir. And thank you so much. And we would be happy to meet you again. So once again, thank you to all the attendees for your active participation. It was really nice to have everyone interacting today. And once again, thank you, Radhakrishnan sir, Akhila ma'am, Nesma, thank you everyone. And yeah, that's also, we've come to the end of our meeting. So